Welcome to our DiLCo Lecture Series on Digital Language and Communication. I'm Heike Zinsmeister from the University of Hamburg. We had a couple of lectures before for those who attended the lecture, but for those of you who are going to attend our lecture series for the first time today, I'm going to introduce the project briefly. DiLCo, our project, is a 3-year scientific network on digital language variation in context. It was initiated in 2021, and it's coordinated by my colleague Yannis Anthropopoulos, who's also here, and myself at the University of Hamburg. Our network includes other scholars from universities in the US, UK, Luxembourg, the Netherlands, and Denmark. And a couple of colleagues are also here today. DiLCo is generously supported by the University of Hamburg with the Universities of Excellence scheme, which is funded by the German federal government and federal states. Our project aims to stimulate scientific exchange between various approaches to digital language and communication research within linguistics, and to bridge the gaps between qualitative and quantitative methods. I invite you to have a look at our websites for our past activities. And then we have our DiLCo Lecture Series, and in this series, the lectures showcase cutting-edge international research by both senior and younger scholars who draw on key concepts in social-cultural linguistics, such as community, context, identity, interaction, multimodality, and also linguistic change, to shed light on digital communication. Okay, as I said, we are recording these lectures to build up a repository that will be available open access from Hamburg University's video portal. It's called Lecture to Go. Please visit our website for more information. And as in the past, this lecture is about 40 minutes, followed by a discussion. Feel free to also post questions and comments into the chat during the lecture. Okay, so people are still arriving. I'm now very delighted to introduce today's speaker, Dirk Hovy from Bocconi University in Milano, Italy. He is an associate professor of computer science in the Department of Marketing at Bocconi University, and he's also the director of the Data and Marketing Insights Research Unit at the Bocconi Center for Data Science and Analytics. He used to work at the University of Copenhagen, and he got his PhD in natural language processing from the University of Southern California in Los Angeles. Before that, he did his undergraduate studies in linguistics in Marburg, Germany. He's interested in the interaction between language, society, and machine learning, and what language can tell us about society, or what computers can tell us about language. I'm like to congratulate Dirk. He recently received the very prestigious ERC starting grant from the European Commission community.
Research Council, yeah.
Research Council. And the project, the Integrator project, is on democratic factors and bias in NLP models. And today he will present very recent work, or even work in progress, also together with another member of the DiLCo Research Network, Christoph Puschke from University of Luxembourg. And Dirk, the floor is yours. We are very happy. Thank you for being with us today, and the floor is yours.
Thank you very much. It's great to be back in Hamburg. It's also great to be in the DiLCo series. It's really exactly my wheelhouse. Yeah, as Heike mentioned, my background is in linguistics, variational linguistics in Marburg, and then I sort of transitioned into computer science and natural language processing. But I've always tried to combine things, and the Integrator project, in fact, is sort of a marriage of the two, or to sort of see what all the things we know from sociolinguistic, variational linguistics can tell us about building better natural language processing and machine learning tools to incorporate knowledge about sociodemographic factors. What I want to talk about today is one stream of my research, and it's an ongoing, longer-term collaboration with Christoph Puschke, a good old friend from Marburg Times, and is sort of really, probably at the core of what DiLCo aims at, namely the combination of quantitative and qualitative approaches. And what I wanted to do today is show you where we are at with a project. So this is hot off the press. I was running experiments until late last night. Then at some point, all my results went away, and I briefly considered whether to cancel the talk for today because no results, no talk. Then I found out, luckily I'd committed a bug. I reran everything, checked thrice, and turns out everything is okay. So, be careful with how you do things. But I thought, even if it hadn't worked, right, in the interest of science, sometimes it's good to talk about failures. Luckily, I don't have to talk about a failure today. I can talk about some interesting results. But we're not, this is not a polished, finished work. This is very much ongoing. I'm going to, signpost a couple of things that we plan to do. But I would really, appreciate any feedback you might have. Probably best to talk about it at the end of the talk. But yeah, really, I guess this is exactly the right crowd to get some good feedback on these things. All right, so let's dive right in. We know that regional accents, regiolects, or dialects, I'm going to use all of these terms interchangeably. I'm going to say that up front, so apologies if that matters a great deal to you. I'm just going to use them very loosely. They matter a lot, and we know that these things have been surprisingly stable, even though regiolects, regional color of language, and non-standard varieties seem to be receding in everyday life. Their local extent, their geographic extent, is remarkably stable over the last, hundreds of years. And what's even more interesting is that these things even persist online. So on the internet, nobody knows you're a dog, so you don't have to perform, a certain regionality, and yet people still do. So this is something that Christoph and I found a while ago, and that is also the basis of the data that we're going to use today. It also turns out that the dialect regions are one of the best predictors of where people will settle and where people will get a home. It turns out people are more comfortable settling in their own dialect region, even if economically it would make more sense to move somewhere else. So the question we started out with was relatively simple. Well, today we don't have the ortsfeste Sprecher. We don't have people who were born, bred, and raised in one village and, only were exposed to one dialect. People do travel, right, for work every day. We, go to great lengths. The average commute is, between like half an hour, 45 minutes, somewhere around there. So we're not confined to where we grow up. And so the question is, how does that affect how people speak? So that's our basic question, and that's what this talk is going to revolve around. So let's say we have a dialect region here, and we have people commuting in and commuting out. Commuting in are the yellow dots, commuting out are the green dots. What does that do with language? What does that do with the relation of standard language and dialect or non-standard language? Does that change it? And, in the absence of sort of data over time, in the absence of panel data, can we sort of can we predict something about the relationship of the two by the commuting patterns that we observe? And yes, I was told people like spoilers, so I'm going to say kinda, and I'm going to leave the details for later. So, hopefully now I got you hooked. But since you already turned up for the talk, I guess I don't have to do too much to get you interested in the topic. So what I want to do today is, explore this impact on regional language and show you some results and then collect some feedback. Now, all of this is based on this here map on the left. This is an outcome of the collaboration with Christoph. And this map sort of nicely shows sort of the, German varieties of German, right? And it nicely shows a continuum from the southeast to the northwest, which sort of gradually changes. The different colors sort of represent different varieties. And we see that Switzerland is separate. Now, I should say this map came out of an algorithm that has no idea about languages, dialects, regionality. This is simply the application of a couple of quantitative tools, of algorithms, to a large sample of data. We had some advantages, and I'm going to talk a little bit about it, but this basically means, there is still this information out there, even in this online speech. So what I want to do today is first establish some of the basics. We have to go over how we got this data, what we did with it, and what some of these algorithms do. And I'm going to stay very high level. If you want to get more details, I'll refer you to the papers, and I'm also happy to answer questions. Then we got to sort of compute a dialectality score for different regions or cities or areas of interest. And then we have to relate all of that to commuter data and sort of feed it into a model to get an answer to our question: how much does commuting influence regionality? So let's dive in. So first of all, we need to take the data that we get, the text that we have, and we need to somehow represent it in a form that the algorithm, that the computer can deal with. And what we want to do is we want to represent not just words, but we also want to represent sort of the linguistic profiles of cities where these words are used. And luckily, there's an algorithm that does that. Now, this algorithm is based in the distributional hypothesis by Firth. You shall know the meaning of a word by the company it keeps, and you're kind of contractually obliged to show this quote whenever you talk about this algorithm. But what it boils down to is relatively simple. Similar words, or words with similar meaning, occur in similar contexts, where context is simply the context, so the text on either side. Now, if we manage to represent words as vectors, as points in space, then similarity, semantic similarity, should be proximity of those points in space. So words that mean similar things, or sentences that mean similar things, should be very close in this vector space. And if we have these vectors, then we can use them as input to a variety of quantitative methods like clustering and prediction, and we're going to do all of those things. What we want these vectors to do is basically capture these semantic similarities. So here's a little illustration. In English, the words flat and apartment are basically synonyms. They're sort of variety, or like regional varieties of the same word. Flats is the British term, apartments the American English term. But we could basically say in a imagined two-dimensional space, we want them pretty close together, like so. And we want them pretty far away from a word that means something different, like platypus. And so these points in space basically have an X and a Y coordinate. So we could essentially combine these and then represent the word flats as the vector 16.3 and 7.8, and the word apartments as 15.9 and 9.3, and the word platypus similarly as 2.3 and 20.6, right? And so now we've transformed each of these words into a, in this case, two-dimensional vector. And what we can do in this vector space is basically say, what are the terms that are close together? What are the nearest neighbors? And then we would hope that that represents semantic similarity. We can use this measure, cosine similarity, which essentially measures the angle between these words. It's defined between -1 and +1. And if we have close to 1, then that means these two words are essentially the same. They're synonyms. If they're -1, that means they're absolute, the opposite. If they're closer to 0, then they're kind of unrelated and occur in very, very different contexts. And there's an algorithm that essentially bakes in this semantic similarity, this contextual distributional hypothesis. And this is called DocToVec in this case. The way I like to describe it is with fridge magnets. So imagine you have a bunch of fridge magnets. These are all the words you've observed in your corpus, and all, in this case, the cities we've observed the words in. Now, initially, we place all of them randomly in the fridge. the words and the cities. And then, because computers are very patient, we, for a long time, play this game where we pick a word and a city. We look through our corpus and we say, have these words occurred together? Or has this word occurred in a document from this city? If yes, then we move them closer together. If not, then we move them closer apart. Now, obviously, if I move a word further away from, say, Hamburg, I might have moved it closer to Munich, but maybe I should move it also further away from Munich. Now, if I only have 2 dimensions on a fridge, then that's a bit difficult, and I might have to repeat this for a long time until I find a stable configuration. If you add more dimensions, then that gets easier, right? You can move things in one direction and keep the distance in the other directions the same. You can imagine just adding a 3rd dimension gives you a lot more degrees of freedom to arrange things in a pattern that satisfied all of these constraints. Now, the nice thing is that if we play this long enough, we essentially end up with 2 things: a representation of the words and their meanings with respect to each other, and a representation of the cities, or the cities' linguistic profiles. And now we can do a variety of things. This is what it looks like. So this is for illustration purposes only. This is very simplified, right? But you can imagine in red the cities, and then in blue you have all the words. And what you would hope to see, and what we in fact do see, is that sort of regional terms sort of tend to be closer to the cities where they occur. And yeah, the basic outcome of this first work of Christoph and myself was that this is in fact happening. This is what is encoded in the data, and we sort of get these very nice vector representations. And then what can we do with it? Well, we can compare the cities to each other, and that tells us how linguistically similar are these cities. We will see we can cluster them based on this, and we actually get dialect regions, or we get linguistically driven regions and areas. We can compare the words to the cities, and that will give us sort of the prototypical words of an area of a city. Because there are vectors, we can also, group cities together into an area and then ask for the words that are closest to that particular area. We can compare words to each other, and so we can sort of get semantic fields, and we can ask about what words occur in similar contexts, and we can sort of see what is the equivalent of Schrippe and Rundstück and all the other words for Brötchen or bread roll in different areas. And last but not least, because these are vectors, vectors are the input to machine learning classifiers and tools. We can attach separate labels to them. For example, we can say, the word Oida is regional dialect, whereas the word sozusagen is standard German, right? So we can attach the labels regiolect or standard German to it, and then we can learn to classify them. And we're kind of going to do all of these things in the remaining 20 minutes. Oh, okay, I need to speed up. So what we did is we got this data.
You started later. You started a bit later,
okay.
So we have some more minutes.
All right. So we got data from this platform Yodel, which is a chat app. Basically, it's anonymous. We don't know who the people are, but the thing we know is their location. And these people can only talk to people within a certain radius around them, around 10 kilometers. So this already imposes a little bit of regional or geographic structure into the data, but it is completely devoid of any other sociodemographic information. What we did is we collected data from 408 German-speaking cities. We actually collected more, but 408 were the ones in Germany, Austria, and Switzerland, where we had at least 200 threads in a city. So the conversations are organized in threads, and then several posts form together a thread. So we got about 2.3 million threads and almost 17 million individual posts. So that's a decent amount of data. And it turns out if we run this doc2vec algorithm, we get these two things here on the right. In red, we get a matrix. Basically, matrix is nothing but a collection of vectors. We got 300-dimensional vectors. Each of these vectors, or horizontal rows, represent the linguistic profile of a particular city. So we got 408 of those. And then we have the word profile, so 300-dimensional vectors that represent words with the sort of constraint that words that have similar vectors occur in similar contexts, meaning they have similar semantics. And if they're close to a city, that means they are very typical for that particular city. And our vocabulary size is I believe, 100,000 and something. So one thing I should note is that people talk a lot about particular places. And if you're in a place, for example, if you're in Hamburg, you're much more likely to talk about Reeperbahn and local things or HSV than you are when you're anywhere else. So the distance from a particular city sort of determines how often you mention certain named entities. So what we did is we tried and this is not what we're interested in, right? We don't want to learn that people in Hamburg talk more about Reeperbahn and HSV than people in Munich. That's not really what regiolex are. So what we did is we scrubbed the data as best we could from any names that refer to places, people, organizations. This is a stochastic tool named entity recognition tool, and that sort of got rid of a lot of the things that are most indicative of where a text comes from, but it also removes the words that are, least likely to be regiolect terms or dialect terms, and more likely to be sort of life world orientation terms, as Christoph has termed it. So what do we do with this? Well, we have a 300-dimensional representation of each of our cities. And again, cities that have similar representations mean they are linguistically similar. So one thing we can do is visualize this, right? We can, for example, assign each city a color, and then we would like to do that in a way that similar colors mean similar linguistic profiles. What we do is we decompose this matrix C into two lower dimensional matrix, 3-dimensional matrices. V and H, we are only interested in the matrix V, which is a 3-dimensional representation of each city. We interpret those 3 dimensions as the amount of red, green, and blue. That is the RGB color. We throw away this other matrix, we don't need it. And then we can translate this RGB triple into a individual color, right? So 100 would be the color red, 001 would be the color blue, 0.5, 0.5, 0.5 is a medium gray. And so we can now map these continuous colors into continuous numbers into continuous colors. And now, apologies. Now we can locate each city on the map and color it with the color that we've got out of it. And what we see is this map, right? So this map came out at 1 in the morning when we were experimenting, and we both looked at each other surprised and thought like, wow, that must have been a mistake. And we reran it, but it always came out this way. So really, this was the proof for us that this does capture regional variation, and it nicely sort of captures the German dialect continuum, but also sort of the separation of like Swiss varieties that are markedly different from a lot of the German and Austrian varieties. The question is, that's a nice map, but does it line up with linguistic theory? Like, is this real, or is this just pretty, right? Well, we do science, so, pretty is secondary. Let's make it line up. So what we did is we got the latest and greatest dialect regions from Lameli and try to link up what we find with those dialect regions and see what is the overlap between the two. To do that, we take our matrix of city profiles and we run agglomerative clustering. So first, each city is its own cluster, and then we group them together into larger and larger regions until we reach a predefined number of clusters. So we go from 2 up until, I believe, 20. And for each cluster solution, we can basically say what is the overlap with the map by Lameli, right? So one of these solutions might look like this. You can sort of squint at it and say, yeah, that kind of lines up in some cases, but not so much in others. But like, how well can I quantify this, right? Well, it turns out we can take the map by Lamelli as the ground truth, and then we can compare our clustering solutions against this in two ways. One is homogeneity, where basically we look at the cluster that our solution finds, and we say, is each cluster contained in one region, which is good, that's good homogeneity, or is it or does it span several of Lamelli's regions, which is worse, right? And we can sort of measure how many of the points are outside of the Lamelli region. And then we look at completeness, which basically takes the other way. We take one of the regions from the Lamelli map and say how many clusters of our solutions are in there. One, that's good, or several, then that's a bit blurry. We can combine these two, take the harmonic mean, which is called the V-score, that basically just gives us a single a single number. We do one more thing where we basically infuse these vector representations with some of the NUTS3 information. NUTS3 is the statistical geographic information that the EU uses, and we sort of add this, or we control for this to sort of include a little bit of information. Turns out when we do this, which is called retrofitting, we get to a V-score of 0.77. So basically, the cluster solutions we find at 16 clusters for the whole German-speaking area align to almost 80% with the map by Lamelli. So that's a fairly encouraging result, which basically means our maps are not just pretty, they also actually capture something that we know from sociolinguistic theory to be empirically true. Now, we looked at some of the outliers. So the most notorious one is Würzburg, which sort of is completely in the wrong dialect region. It turns out the app that we're using is very popular with students, and it turns out that the vast majority of students in Würzburg are actually from more central Bavaria. And so actually Würzburg presents as this outlier of the dialect variety we have in central Bavaria. By the way, if we simply take the NUTS regions, which are the communities and states in Germany, if we take the NUTS2 regions, we basically get a V-score of 72. So our system, which is only based on the linguistic profiles we find, is markedly better than that. What does that look like? Well, this is what 3 clusters look like. We have Switzerland as a separate cluster. Then we have Austria and the German south. So you sort of nicely get the Benrather Linie here, sort of bisecting Germany in the middle. And then you have the Low German varieties. 5 clusters, you get more separation in the West Central German varieties. So in the German West and Southwest, so you get Swabian, you get Rhine-Mosel-Franconian and West Upper German. And then as you go on to like 16 clusters, you see that you get much, much more fine-grained distinctions in the German Southwest. Here you see Würzburg being this outlier, which should actually go with Regensburg, München, and the other places, but that's because of the student migration, and that sort of seeded what I'm talking about today back then. And you see that the that the Swiss regional varieties are super fine-grained. In fact, they sort of make it possible to locate where somebody's from down to like 12 kilometers. We sort of tried that out. In comparison, in Germany, you can locate somebody down to like 200 kilometers, which is not super exact. Now, if you match up the linguistic profiles with the word representations and you look for the nearest neighbors, you get something like this. So for Vienna, the closest ones are Leiwand, Bissi, Ur, and other. You get some spelling variations of Herst. And these are, traditional regional dialect items. You also get things like Jodel Confession and Loco. Loco happens to be a club in Vienna, as we learned. We couldn't filter that out, apparently. Also, we missed Schwedenplatz somehow. So those are things that are local to Vienna, and people talk about it. But obviously, these are not dialect items. But you can see they're actually further removed. We can do these prototypes also for regions. So if we do the 3-cluster solution, we can ask we take the centroid of the cluster and then we say, what are the words that are closest to the centroid? And you see for the blue region, you get standard German, ja gut, erstmal, sieht drauf, vielleicht. For the south, for the red region, you get dialect terms, einfach, voi, and ia, oder. And then you get like Swiss dialect terms, esch und wel, gard, rüki, nöd, for the green region. So, again, sort of, and this is where the qualitative rubber meets the quantitative road. We can now look at these things and relate this qualitatively to our knowledge of regional varieties, of German varieties. And we can see that the quantitative solution that we found, right, this is simply an application of linear algebra, actually results in qualitatively interpretable results, right? So this is really this marriage of the two. And so once we're at this point, we have the style profiles of the city, we have the word representations, we can sort of compute dialectality of different areas. Now that requires one additional step. Namely, we need to look at a word and say, is this word dialect or is this word standard German or something else? And after some initial analysis, Christoph devised this taxonomy of 7 different categories: standard German, traditional redialect, these are the ones we're going to focus on. Medium-specific terms, these are things that are specific to Yodel as a platform. Life world orientation terms, these are things like Schwedenplatz and Loco, so things that sort of got through our filter. Items of online communication are smileys and emoticons. Typically, foreign words are mainly French words, especially from Switzerland. And then community-specific regional terms are kind of, well, there's somewhere between medium-specific terms and traditional redialects. They're sort of new regional variants that come up. We're not going to talk about it here. We have some mentions of that in the journal paper that we published, so I'll refer you to that. And I'm sure also Christoph will be happy to talk more about that. And, we might get back and work on this separately at some point. So what we want to do is basically take a word, which is equivalent to a 300-dimensional vector, take the correct label we have for it, hand that to a classifier, a machine learning tool, and say, if you see a vector that looks like this, then this is the answer we expect. And that's called training a classifier. Now, we did this with a couple of thousand items that we hand labeled. And then we tested this classifier, and it achieved pretty good predictive performance. And then once we have this classifier, we can, we couldn't label 100,000 words, so we only labeled a small subset. Once we were happy with the performance of the classifier, we can apply it to all of the words in our data. So pa, su, park, vielfach, sa, nahe, und few. And we can ask the classifier, what do you think these words are? Right? And it will come back with these answers, which happen to be correct. And actually, it usually also has a fairly high confidence in these answers. So that, again, to us was a qualitative confirmation of the application of the quantitative tool. Okay, so now that we know for each of our words in our vocabulary which of these 8 categories it belongs to, and we know how often it occurred in each city or dialect region that we determined empirically, we can compute what is the overall ratio of each of these categories in that particular city, region, area. And so here's what it looks like if we aggregate by country, right? So we look at all of the words we see in Germany, and we look at which share of them is standard German, traditional regional items, life-world orientation, and so on and so forth. And we do the same for Austria and for Switzerland. And you see at one glance that the proportion of traditional dialects, of redialects, increases from very, very low in German, actually one of the lowest of all the resources, to much larger in Austria, and a very, very large, the majority share in Switzerland, whereas proportionally the amount of, or the ratio of standard German items decreases. We can put this on a map, and then, we'd sort of see how standard and dialect differ. You can sort of see these things here. Obviously, everything is driven by the strong values that we see in Switzerland, which sort of like bleach out the colors in the entire rest. Sorry. We can break it down by city. Here is just a selection of cities throughout the German-speaking area. And again, we see it follows the same pattern. Interesting here to see differences between, in Switzerland, for example, Zurich and Bern, which differ markedly in the amount of traditional dialect versus standard German, but also in Vienna, look at the difference between Vienna, in Austria, look at the difference between Vienna and Linz, for example. Whereas in Germany, it's relatively stable across the board, but you do see that as we go from north to south, the amount of dialect increases ever so slightly, not as much as in the West. And then we can also do this by cluster. And again, we essentially see the same thing. And yeah, we see that sort of Bavarian in Germany is probably the dialect area which has the most traditional dialect terms, although again, not as many as we would see in the different varieties of Switzerland, for example. So the question is, how do we relate this to commuter data, right? So we can now get a dialect score or standard German score. Those are the two we're going to focus on for each city, for each region, for whatever we want, right? And we can aggregate at different levels. The question that we started out with was, how much does the region, whatever that is, and we're going to talk about that in a second, affect people's commuting, right? How many people commute within their region? Well, how many regions are we talking about? We're going to focus on Germany here because this is where we have the data for. We can start with one region, right? That's the minimum we have, just Germany. And then, well, everybody commutes within, except for a few, like very few people out of the millions commute across the border. So, basically then almost 100% is intra-commuters, intra-regional commuters. On the other end of the spectrum, we could use the NUTS 3 regions. There are 412. And if we use those, then, still actually a surprising 19% of people commute solely within their region. Obviously, this is a bit unwieldy and a bit odd. So we could go down to 38 regions, which are the NUTS 2 regions, is basically similar to German states, a bit smaller. And here we see that still 56% of all people commute within their region, right? In comparison, I ran a cluster solution yesterday with 38 clusters in Germany based on our linguistic profiles. And we actually see if we use the linguistic profiles, we see that more people stay within their region. So this goes back to this first question. People seem to prefer to actually stay within their dialect region, even for commuting, right? And so this actually explains more of this variety or of this variance than the strict statistical geographic regions. What we're going to focus on is the 11 dialect regions, which is the clusters within Germany of the best clustering solution we found, the 16 cluster solution on the entire German-speaking area. And in this solution, 84% of people stay within their own area. If we go down to 4, then it's 92. So it sort of goes up very, very quickly. But we're going to focus on this in the following. And we're going to use this and make a partial result out of it and say, RegioLex actually explain more about people's commuting patterns and preferences potentially than does pure geography, right? So this does say something about the primacy of language and the sort of comfort we have in our home region and our preferences to stay there. Now we combine this with publicly available statistics by the Bundesagentur für Arbeit, commuter stats. And here we have in-commuters and out-commuters. So in-commuters are all the people that come from everywhere and go into Hamburg to work. And out-commuters are people that live in Hamburg and commute somewhere else. Typically, out-commuters are smaller, or a lower number for cities like Hamburg than the incommuters. Nicely for us, the Bundesagentur für Arbeit actually breaks down, stratifies the incommuters and the outcommuters into demographic groups. Men, women, Germans, and they call it others, so I guess non-native German speakers, and also Azubis, so people who are doing an education. It turns out this is sort of a category that doesn't really apply here for us, but we'll see that in a second. So now the question is relatively simple. We have the official Bundesagentur für Arbeit stats of how many people commute in and out from each of these different sociodemographic groups. We can put that into a linear regression and we can see how well does that predict what we know from our aggregation of how much dialect and how much standard is spoken in this particular region, right? So we take these two quantities we have, we use one of them as the input variables and the other one as the output variables, and we say, can we find a function that takes as input the commuter variables and outputs how much dialect or how much standard is spoken in that region, right? And if we can find a significant, somewhat reliable relation between the two, if there is such a function that takes as input the commuter patterns and outputs the dialect, then that is not proof, but that is an indication that there is something here, right? Note that we could also reverse this order, right? We could say, if I tell you how much dialect is spoken in a region, can you tell me the commuting patterns? We did try that, but there's not much there. It's a much more impoverished model because you have fewer inputs, but it's also a weird causal underlying story, right? Because what does that mean? We observe the dialectality in a region, and that affects how people will commute. That seems less likely an origin story than people commute, and where people commute from and who those people are affects how much dialect or standard is spoken in that particular city, right? And that is what we're going to focus on here. Now, I was saying earlier, before the talk, that, I was running experiments up until yesterday. I was like, oh, in the interest of good science, I will, rerun everything from scratch to make sure that the results all hold and that everything is as we know. I'd already made my slides, put in all the numbers, I reran everything, and boom, everything exploded. No results, nothing of significance, no correlation to speak of, basically no pattern. So I said a few choice words and then briefly considered whether I should actually cancel the talk. But then I thought, well, what the heck? I mean, this is science, right? We should be honest about our mistakes. Let's also talk about the mistakes. But then I went through it again, and I actually found out that the mistake was, well, sits in front of the computer. I'd introduced a bug that essentially destroyed any mapping between the cities on the left to the cities of the right. So if you randomly assign the output to the input, well, yes, there's no pattern. So what we've proven is our results are better than random. So that's, the positive spin I'm going to put for it. But there are still issues that we know from this. I should say that the results we have now are triple checked and they hold. But there are things that, we still are struggling with. We have 333 cities in Germany in our dialect data. Only 84 of those are matched in the commuter data. Part of that is string matching. Things are called weird stuff like Regionalhauptstadt so-and-so instead of just the name of the city. You can sort of filter that out. But then there are other things. There are cities that we have in the data that are sort of aggregated as like Rhein-Main region or something like that, or Kinzigtal or whatever. So, these we still have to update. The positive takeaway here is that as we sort of add more cities to this, the results should stabilize. Okay, so here are the results. All of these results are significant at a p of 0.05, so standard p-value, except for the ones that have the dashed outline. Those variables are not significant. If the bar points to the left, then that means this variable is a strong indicator for the dialectality in a region. And if it points to the right, then it's a strong indicator for the use of standard German in that region. So I should point out that women outcommuters and others outcommuters did not pass the significance test. They were just over it. This might change if we have more data, which would make the pattern much more symmetrical. But oh well, this is what empirical data is, right? Our R squared, our correlation between these variables is around 18%, which is not fantastic, but it's not terrible. It means there is a weak correlation, there is a weak pattern. Now, interestingly, it seems that sort of men or women, it doesn't matter if people are commuting in, then that increases standard German. This might have to do with sort of the pressure to perform towards the standard when you commute to your workplace or at the workplace. This might have something to do with attitudes. This is something we want to look into next. And we see that sort of the, let's say, native background of people says something about the impact on regiolex. Interestingly, also men commuting out. This means for every percentage increase in men commuting out, we see about a 2.4% increase in dialectality, or in the ratio of dialectality to standard. Now, the model I used is ordinary least square, so the simplest linear regression. Start simple and then be more complex. One issue we already know is that linear regression is not very good when your dependent variable, when your outcome is basically a ratio of two things with respect to each other. So we might have to try other models here that are more in tune with what we're looking at. But again, the takeaway message is if a simple dumb model already gives you some pattern that is reliable, as we see here, with significant results and a acceptable correlation, then a better model should only increase that score. So this is what it all boils down to. Yes, we do in fact see an effect of the commuting patterns on the predictability on the distribution of standard and regional variety use in particular regions, in this case at the city level. Here we can't aggregate to a higher level, say, of dialect regions, because then we would go down to a very small number of data points. Now, this is where we stand, and this is where I'm going to leave you and like open the floor for feedback, questions, accusations, no, hopefully more maybe praise, maybe thoughtful commentary. But there are other things we want to look into. The levels of dialect acceptance, how appropriate do people think it is to use dialect in the workplace, in the pub, with friends, with, you know, like in bureaucratic interactions. What are education levels, unemployment levels? Those things might have an effect. The later two are relatively easy. They can be gotten from geostats or Eurostats, and we could factor those in. We might want to factor in sort of the size of the cities and things like that. And last but not least, we would like to incorporate dynamics, but obviously that would require panel data. We have a little bit of a semblance of panel data because we did two collections of the dialect data, or of the social media data, and we have obviously commuting data from different years. But that's, you know, future plans. So that's it. What I want to leave you with is a couple of takeaways. Using these embeddings that you can learn from data is pretty cool. It does capture regional variety to the point where we can actually display the German dialect continuum, German-speaking dialect continuum. It helps us recover or pinpoint resources and styles and dialectality. And we see that regional dialectality, regional dialects, regiolex vary greatly across the German-speaking area, but they define regions much better than does pure geography, pure statistical geography in the preference of people to commute. And we see that it also is weakly predictive or definitely correlates with people's commuting patterns. So that means commuting in and out of cities and dialect regions does seem to have an effect on the changing relation between dialect and standard. And with that, I'm going to leave you. I say thank you very much for your attention. Thank you for all the questions and thoughts you might have. And if you have questions, let me know.
Thank you very much. I just would start with the first question, and I'm also picking up Dana Römling's question in the chat. So could you explain the impact on resources slides? Can you understand this? Germans and others, both when they come in, there's more dialect, both when men and women go out, there's more standard. So could you explain the categories? Dana put it this way: how does group membership work? If I am a non-German Azubi coming in, am I in two groups? Could you explain that?
That is a good question. I believe that these are double counted, so that people are, because these are overlapping categories, right? So I believe that these are then accounted for all of them. So I should say that everything here is normalized by the official totals that the Bundesagentur für Arbeit provides, so that we're always working with percentages. So that sort of controls for differences in city sizes, but also in the group sizes. So all of these are expressed as percentages.
Okay, but if you think of a category with two possible outcomes, like Germans and others, or in the simplified view, men and women, how can we explain that they go to, because they should capture all?
Yeah.
In binary categories, yeah.
Yeah, that's a good question. I mean, we might have to dig into the data and see whether they have like disaggregate or like differently aggregated versions of this data and see how that affects the results. Yeah, that's a good point.
Jack Grieve.
Hi, Dirk. Thank you. Yeah, I got a quick question. So I'm just wondering, like, so if these word embeddings like encode all this regional dialect information, right, which is really nice, like for dialectologists, but I wonder, like, what do you think about that means for like people who are using word embeddings, not for studying social meaning, right, but for studying like referential meaning, like the sort of standard use of word embeddings, right, like as a way of representing the semantic similarity between words, right, not their social similarity or something like that. So I just wondered, like, is this like a source of bias, and is it maybe like, is it both a kind of evidence of like a bias that's arguably problematic, that this, and then on the other end, is it bias like problematic socially or like from a ethical standpoint, but is it also maybe bias that's problematic from like a from processing referential meaning, like this, like you kind of if these words that are if these words that have that don't share referential meaning but share social meaning are sort of pushed closer together, does that maybe slightly complicate the use of embeddings for studying referential meaning or for applications involving referential meaning?
So yeah, those are super good points, and this is somewhat at the core of the integrator project. The answer to both your question parts is yes, absolutely, right? So there's plenty of evidence that the way that embeddings are derived, or the sources of which the embeddings are derived, and the way in which they are derived do affect or introduce bias into sort of predictive uses of them, or into semantic similarity uses of these embeddings. Now, these embeddings are called non-contextual, right? So they're sort of, which is a bit weird, but they're static, right? So I train them on the data, I'm using context, but I'm basically training them, and then they are what they are, right? They don't change. There are contextualized embeddings where the representation of each word is different depending on the sentence in which it occurs, right? So this is a model called BERT, which is the latest what is used. And people have shown that this is better predictively, partially because it does escape the contextual factor of meaning of words. It doesn't address this regional factor and the socio-demographic factors that are still embedded in there. And we have published work recently that shows that even these contextualized embeddings are prone to encode social biases, prejudices. So they are prone to sort of reproduce prejudices against minorities, against women, against trans people, against the LGBTQI community. So there's, everything that is represented explicitly and latently in the texts on which we train these models makes its way into these representations, into these embeddings, right? For the good, right? So that we can recapture these regional variations, and for the bad, right? So in our case, we use this as a diagnostic tool, and we want to learn something about language use. But obviously, if you use these embeddings as input to a decision-making system, that poses some ethical questions, right? And yes, absolutely. And this is an open discussion in the community that I'm very engaged in, and there's a lot of work we have published and are currently working on. So yeah, absolutely, yes.
Thank you. That's really interesting. Thank you.
Yeah, Yannis?
Yeah, thanks a lot, and also for the very clear explanations. I think I understood almost everything. I have two interconnected points. One is that from a more critical sociolinguistic perspective, the first objection that would be raised is that you're here reducing the extreme heterogeneity of urban commuting and of urban languaging into a binary of Germans and others. And so the entire, everything else basically falls off the board. That is connected to a second question on whether all the work that you want to do on commuting and language preferences will depend on the Yodel data that you've already collected, or whether you plan to collect more social data, and if so, what could it be? And the constructive, maybe constructive hint or idea that would go with that is that if there would be a way to find out whether immigrant people, so newcomers to Germany who commute, show different patterns of learning German or advancing German in their German competence than those who don't commute, that would be really interesting, I think. So, but is there a way to find that out without tapping into people's whatever telephones or something?
Yeah. Well, that poses a whole host of other questions and issues. But yeah, these are good points, right? So the tools we have limit the things we can do, right? In this case, the data by the Bundesagentur für Arbeit, Bundesagentur für Arbeit, we were actually delighted to see that they disaggregated by, Germans, non-Germans, men, women, Azubis, a slightly weird choice of 5 categories, but, we actually didn't expect them to have any distinctions. We just thought it's like in and out, and that's it, right? So it is slightly better than what we would have liked, but, obviously you're correct in saying that this reduces the complexity of the whole thing to a laughable number of categories, right? To some extent, whenever we do this modeling, right, we're forced into compromise land, right? We need to make do with the data, with the tools, with the models we have. The hope is that if we find reliable patterns and findings, even with all of these constraints and limitations and simplifications, right, that would be an indication, and that would hold if we had then the full range of information, right? So all models are wrong. All models are simplifications. Like if you go back to Faust, right? It starts out with the Faust complaining about that, he only has models of the world, but he wants to really understand how the world works. And, we can never really get the world unless we tap into people's phones 24/7 and, then have a computer to crunch all of that data. Ethical issues aside. So, the hope is that even with all of these limitations and constraints, we might find something that tells us, at least a little bit, right? So with all of this modeling work, we always have to, bake small bread rolls, or kleine Brötchen backen. We have to set our sights low, right? And we have to accept that, within this sort of, it's like a board game. It's like we have set an artificial set of rules and constraints, and we say within this little world that we have now mapped out, we can explain things, right? And we hope that the rules for our little game are similar enough to the real world that the conclusions we draw in our little toy world, in our little game, right, port to the actual real world. But yes, it is a simplification. And to your questions, we could run this on different data as long as we had information about the location. In fact, I have run the same thing for review data that came with location information, and sort of recovered dialect regions in England, which was actually fairly nice. So the method sort of is broadly applicable. This is the other nice thing, because it's basically the application of matrix multiplications, right, of linear algebra. Whenever you hear AI, machine learning, or NLP, replace that in your head with matrix multiplication. It sounds a lot less cool, but it's a lot more accurate, right? But, you know, this sort of like objective, sort of unbiased application of very simple, straightforward mathematical operations, right, results in qualitatively interpretable results as long as the input data fulfills one criterion, that is an attached label of where it's from, right? So yes, we could expand this to other data. And this is sort of the big question, right? Like, AI did not grow by better algorithms. There's a nice graph that shows that the solutions to the big AI problems, the algorithms were on average published 25 years before the problem was solved. What changed in those 25 years until it was solved? We collected enough data to make those algorithms work, right? Or better data, or, you know, more representative data. And that really is where it's at, right? So the expressiveness, the size, the representativeness of your data, that is the limiting factor in all of these things, right? So if we found a source, an ethically, you know, not questionable and ethically approvable source of, you know, immigrants, commuting patterns and German learning, that would be wonderful, right? And that would make a very nice test case for all of these things.
Thank you very much. I think this was a nice closing statement. And I would like to say thank you again, Dirk, for the lecture, the very good explanations. And I also like to announce the next DiLCo lecture, which is already going to be next week. It is on the 27th by Axel Bohmann, and he is from the University of Freiburg, or was there some change? I might
yes,
missed it in the beginning.
Axel is stepping in for Lars Hinrichs, who is not gonna be able to make it, but the data they will use are similar and are interrelated. Yes.
Okay, so next week, same time, different Zoom link will be the next DiLCo lecture with Axel Bohmann on linguistic dynamics in digital diaspora communities, the case of Nairaland. I don't know how to pronounce this.
Nairaland, Nigerian diaspora on the internet. Yeah.
Okay, so Dirk, thank you very much again, and see you all at one of the next DiLCo lectures.
Thanks for all the questions. Thanks, everybody.